we identify the first function by using their tag, right? So which function is first here since we have two functions?
Inverse.
Inverse, inverse of trigonometry, right? The first function before algebra, right? So we're gonna use part by part because we have two functions that are multiplying each other. So we identify the first function to be our f of x, which is the inverse. We also identify the second function to be our what? Our g prime. So what is the derivative of this? This is 1 over 1 plus x squared. And this one becoming integral x squared over 2. So according to the formula of part by part, we need to start with f of x. Our f of x is what? Arctan. Multiply by g of x, x squared over 2 minus integral of the what derivative. What is our derivative? 1 over 1 plus C sharp, isn't it? And then is g of x is dx. So we said this is already part of the solution, meaning already I have 1 over 2 x squared tan x. It's already part of the solution, right? What is our constant here?
1 over 2.
Negative 1 over 2. So inside will be left, on the numerator will be left with x squared, on the denominator will be left with 1 x squared dx. So it means here, since you guys are preferring use substitution, if it's quotient, you will use quotient, but it's not quotient, right? It's not quotient because the exponent of the numerator is the same as the exponent of the denominator. So our fraction is an improper fraction. So when the fraction is improper fraction, we need to use Elong division method. So that's what we're supposed to have learned. So Elong division method will apply when the fraction is improper. So it means we're given an algebra. So we can only use. So before we continue with that one, let's learn on how to work around long division. So we can use Elong division when we have an algebraic function. So what is happening? It means the exponent of the numerator and denominator, they must be the same, money. So the exponent of the numerator must equal to what? To the denominator. Or the exponent of the numerator must be greater, né? Greater than denominator. So if we have a higher exponent on the numerator, we're still using Elong division method. It's a sharp, isn't it? Let's just find a problem. We do it separately, then we're gonna also continue with where we have stopped on that part by part, just to show you how the long division method will apply. So on that time, we will not be able to integrate using the quotient because of that condition. So if we have x raised to power 3 plus x divided by x minus 1, we can easily see that this is a what? along division, because the higher degree of the exponent is 2 and the higher degree is what? 1. So this we call it improper. So the moment you have a higher degree that is higher than the denominator, you know you must use it on division. Or maybe the exponent are the same. Yeah. So according to long division, you take your numerator to be your f of x. So our function, we're going to put it there, and then we take this to be our vector. So this is the denominator become our vector. So what we're going to do, first of all, we're going to take this, we divide the first term, divide the first term. So when we divide, we have what? X squared. So after dividing, we are taking x squared, it must multiply. So when it multiply the two terms now. So this time is this give what? X cubed. C sharp. And this time is this, it give us what? Negative what? X squared. So what we can do here on this function, we can write it from power 2, power 3, power 2, power 1 until constant. So it means with here I can show so basically on a normal circumstance I'm supposed to have 0x squared plus 0 plus x, because we give an x plus what? 0. So what will happen here? We need to introduce what? A negative. So when you introduce a negative, simply means it changes the sign of the inner part. So this meaning now is negative, this one is what? Positive. So what will happen? We're going to add, so this it will be 0, we agree with that? So here it means it's 0 plus 1x squared is still in x squared. Then you drop the remaining terms, which is x plus 0. So now you start the process again. If first term, meaning it will divide this first term. So when it divide here, it become what? X. You write it on top. So this x times this one, it gives us what? X squared. This one times this one, it gives us what? Negative x. So when you introduce a negative, meaning it will change the sign inside. This negative, this is what? Positive. So this becomes 0 and we add, and this become what? X. 2x. Again, x divided by x plus 2. C sharp, isn't it? This 2 you multiply there, 2x. This time is this, negative 2. Remember this is like plus 0. Yeah. So you introduce a negative, it will change the sign inside. So this is negative, this is positive. So this is 0, this is what? Plus 2. So this is our what? Our remainder. So what is the formula to integrate after when you have done your division? You're going to say it's solution, integral of the solution plus remainder divided by any effect. So that's the formula that we need to use. So a remainder here, so you replace our part. So a solution is our quotient. So we call it solution or quotient. And then effect is this one. This we call it effect. So there's the formula on how we're going to integrate working with field of division. So it means you take your solution, you put it inside the integral. So our solution is x squared plus x plus 2. Plus a remainder here is what? 2. Is 2. Factor x minus 1 dx. Don't forget to put the dx there. So it means we'll integrate this and integrate this. C sharp, isn't it? The integral of this you can integrate, you add the one, this one over this one
2x.
Yes. What is the derivative of x? 1, So we can take a constant outside, you take 2 as a constant so that the derivative of this is 1, and the derivative of x is 1. So if it's 1, you can just add in of the denominator, or use your substitution. So 2 in of the plus 1. Yeah, that's how we work with long division. So that's why here we say it's long division, because the degree with the what? The same for the exponent. Power 2, power 2. So it's proper. So we're supposed to take this, we apply our long division from it by saying, meaning here you're gonna write it in order. You start with the degree to the constant, and then inside you have that. So this, when you divide the first term, what are we going to have? 1, this time is this, x squared, this time is this, plus what? 1. So it means that we can just go straight to 0, so that they will match. So we have introduced a negative, whereby this becoming negative, and this become what? Negative as well. So what will happen? Meaning this is 0, this is what? -1 as a what? Remainder. So when you have that, I said you will follow what? The formula. So remember, Tina, we're having this as part of what? The solution. So let me erase it. We're having that as part of the solution. So it simply means we're having this as part of the solution. We have a constant outside, so want to use your long divisions also in the open brackets. Then it's solution plus remainder. So a solution, what's our solution? We are using that formula, Solution here to manage. So it's integral of 1 dx, plus a remainder here to is -1 divided by what? Our factor. What is our factor? 1 plus dx, so you can take this negative that side, so let's multiply. So when you multiply, this equal to -1/2 integral of 1 dx. When you multiply, it will be, remember you have taken this negative, so now here it's negative, when you take this out, this become negative, so and there's a negative outside. Negative and negative result in a positive 1/2. So this is what we have to integrate now. So this is already part of our solution, and then what's the integral of this? 1/2. So integral of this
X.
We have a constant which is 1/2. What is the integral of this? We reverse from dy dx back to original. Plus